Hi, Assalamualaikum and very good day to all. Today you are going to learn about chapter 2 that is on differentiations. These are the objective of today's lesson. Hopefully, by the end of this session, you should be able to 1. Define the basic concept of differentiations and 2. Differentiate functions using the definition of differentiation, which is known as the first principle. Differentiation is a technique to measure how a function is changing at any point, and it is used to calculate the gradient of a graph at different points. If y equal to fx, then dy over dx, which is equal to f prime x, is a value of the derivative of the function f with respect to x, or the rate of change of y with respect to x. The process to find the f prime x is called differentiations. The formal technique for finding the gradient of a tangent is known as differentiation from first principle. By taking 2 points on the curve that lie very closely together, the straight line between them will have approximately the same gradient as the tangent. Suppose we want to find the gradient of the curve fx at a general point x equal to c. Choose another close point x equal to c plus h, where h is a small value. Hence, the gradient of the tangent is equal to the limit of fx plus h minus fx over h as h approach to 0, or in the short form, limit of delta y over delta x as delta x approach to 0. Here, delta y refers to the change in y and delta x refers to the change in x. This is known as differentiation from the first principle. Refer to example 1. You need to find the derivative of the given function using definition of derivative, which is also known as the first principle. First, write the formula of the first principle. Next, determine fx plus h for the given function. As fx is equal to x, then fx plus h is equal to x plus h. Substitute this into the formula and simplify the limit. You will get x plus h minus x equal to h. So, h over h is 1. Thus, the limit of 1 as h approach to 0 is equal to 1. Therefore, the derivative of the given fx is equal to 1. Basically, there are 4 steps that you need to follow when finding the derivative using the first principle. Now, refer to example 2. To find the derivative of the given function using the first principle, first write the formula of the first principle. Next, determine fx plus h for the given function. As fx equal to 3x minus 2, then fx plus h is equal to 3x plus 3h minus 2. Substitute this into the formula and simplify the limit. You will obtain 3x plus 3h minus 2, then minus with 3x plus 2, you will get 3h. 3h over h is equal to 3. Thus, the limit of 3 as h approach to 0 is 3. Therefore, the derivative of fx is equal to 3. Proceed with example 3. You need to use the definition of derivative to differentiate the following functions. A is a polynomial function. By applying similar steps, fx plus h is equal to 10x squared plus 20hx plus 10h squared minus 3x minus 3h. Substitute this into the formula and simplify. You will get the limit of 20x plus 10h minus 3 as h approach to 0 is equal to 20x minus 3, which refers to the answers for the derivative. B is a rational function in which fx plus h equal to 6 over x plus h plus 1. Substitute this into the formula and simplify. Then replace the h with 0. You will get negative 6 over x plus 1 square as the answer. C is a radical function where fx plus h is equal to the square root of x plus h minus 1. Substitute this into the formula and serve the limit accordingly based on what you have learned in the previous lesson. That is by multiplying both numerator and denominator by the conjugate of the third, that is square root of x plus h, then plus with square root x. Simplify, replace the h with 0. You will obtain 1 over 2 square root x as the answer for the derivative. D is a combination of rational and radical function where fx plus h is equal to 3 over the square root of x plus h, then minus with 4. Substitute this into the formula and simplify the function first by cross multiply. Bring 1 over h to the front and multiply both numerator and denominator by the conjugate of the third. Simplify once again and replace the h with 0. You will get negative 3 over 2 square root x multiplied with square root x minus 4 with the square as the answer for f prime x. Now, refer to example 4. You need to find the derivative of the given function using the first principle. First, write down the formula of the first principle and substitute the fx plus h and fx and simplify. Split the limit into two. First limit involves the polynomial function and the second limit involves the radical function. To solve limit of polynomial, you may apply direct substitution and you will obtain 2x as the answer. However, for limit of radical function, you need to multiply both numerator and denominator by the conjugate of the third. Simplify the function and replace h with 0. You will obtain 1 over 2 square root x as the answer. Therefore, the derivative of fx is 2x plus 1 over 2 square root x. In order to check your understanding on this lesson, please do the following exercise. Following is the summary of today's lesson. Number 1. Differentiation is the process of finding the derivative of a function fx. Number 2. The derivative of fx can be determined using the definition of derivative, which is known as differentiation from the first principle. Number 3. Basically, there are 4 steps to be followed when using the first principle. In the next lesson, you are going to learn about rules of differentiations. So,